So question 4 is doing a t-test, and it's a two-table t-test. We've got one of our samples and a second sample, so it's a two-sample t-test. And we're wondering whether the fertiliser that the farmer uses changes the weight of the tomatoes from one crop to the second. So we're first of all needing to state the null hypothesis, and the null hypothesis is always the mean of the first one is equal to the mean of the second one. So we're assuming that there's no difference between the samples and that nothing has changed with the change of fertiliser. The second one is to state the alternative hypothesis. So we need to read the question carefully here. Sometimes it's more, sometimes it's less, sometimes it's just different. So it says that the farmer is interested in to know where one fertiliser works better than the other, and if it creates bigger tomatoes. We don't know which fertiliser is going to create the bigger tomatoes, so we don't know which is going to be the bigger one. We just want to know if there's a change. So we're saying that they're not equal to each other. We don't know in what way, we just know that they're not equal. So that would be your alternative hypothesis. And then we need to turn to the GDC to find the p-value. So we're going to open up a spreadsheet and type our data in. So the first one is A and the second one is B. And we're just going to type the data in. So that's the first data. And then we're going to type the second one in as well. So this sample is slightly bigger, but that doesn't matter. It doesn't matter if they're the same size or different. So to do the t-test, we do menu, statistics, stats tests, and it's a two-sample t-test. And we've got the data to input. So the first column is A and the second column is B. So they're the two lists that I'm looking at. And then I'm using that same one. So they've called it 1 and 2, whereas we've called it in the exam A and B. And we've just said that the mean of A and the mean of B are not equal. We always need to change it to say pooled, yes. And then we click OK. So the p-value is therefore 0.413 to 3 significant figures. So 0.413. And that's the p-value of the test. Then we need to conclude whether the farmer should accept the null hypothesis or not. So if we imagine what this looks like, we have our distribution and we're doing a 5% significance test. So that means that 5% is on either end, which means that we've actually got 2.5% this side and 2.5% this side. And our test is 41%. So roughly 20% of the data is this side and 20% of the data, so I've just halved roughly my p-value, is this side. And therefore I'm well into the normal part of the graph. I'm not in the dodgy end at all. So therefore we can use as a justification that 41.3% is far bigger than the 5% significance test, and therefore we accept the null hypothesis. So we're accepting the null hypothesis there. And we leave that as the final answer.